Alright, in this video we're talking about functions and relations. If you remember, relation is like a graph of an equation that we have found ordered pairs for and are able to graph it in the rectangular coordinate system. Functions are special types of relations. And the graphs actually are special too. They look very the way that they look is special. Functions are like machines. X values are placed into that function or that machine as an input value. The machine is then used to generate one and only one value for that function. We use the notation f of x to be ejected from the machine or as an output. So you could think of the machine as doing something mathematical to whatever number you're putting into it, and then it spits out an output. Now the input that we put into the machine or into the function is called the domain of the function. So you're going to hear this word used quite a bit when you talk about functions. And the output that you get is known as the range or the y value. So the x value goes with the domain and the y value goes with the range of the function. So those are two very important words. Now in the instructions here, this says decide whether each relation defines a function. If it does, give the domain and the range of the function. Now, for a relationship to be a function, what you have to keep in mind is if you have x values, and they're all different. For this case, in f here, this set of points, your x values, you have 1, you have -2, and you have 3. Notice that none of the x values repeat themselves. Therefore, we know that this is a function. If they don't repeat themselves, then it is a function. Now, if you were to repeat an x value and it give you a different y value, that would cause this relation to not be a function. But in f, this is a function. Okay, and if we want to describe the domain, then we're going to talk about the x coordinate. So the domain is going to be the points 1, -2, and 3. And the range of the function will be the y coordinates. So 2, 4, and 4. And it does not matter if your y values repeat themselves. It only matters if your x values repeat themselves. So look at the set we have of points here in G. We have 1, we have 1 again, and we have 1 again. And notice not only do we have 1 repeating themselves, but the y value, they give you different y values for each point where x is 1. That means this is definitely not a function. It may be a graphed relation. You could graph those points in the coordinate plane, but the graph or the relationship does not represent a function. So in f, that is a function, and in G, it is not a function. Here are a couple other ways we could represent this situation. Decide whether each relation defines a function. If it does, give the domain and range of the function. So in this function f, we have x values or inputs. We have 1, -2, and 3. So there's your domain, and your range is 2 and 4. Now notice you don't repeat yourself on any x values. Each x value maps to one specific y value. Now the 4 here is repeated, but that doesn't matter. It doesn't matter if y values repeat themselves. So in this case, the domain would be the set 1, -2, and 3. And the range would be the set 2 and 4. Okay, so this f definitely does represent, this is a function. Now look at the h setup relationship we have here. -4 maps to 1. -2 maps to 1 and to 0. So actually it's being mapped to 2 different y values. That's repeating itself. So this would not be a function. You can't repeat the x value and get different values for y. So this is not a function. Okay? One way you can tell whether a graphed relation is a function or not is if it passes the vertical line test. The vertical line test says if each vertical line intersects a graph in no more than one point, then the graph represents a function. Let's show you what this means. In this example, I have two different graphed relations in the coordinate plane. Now, if it passes the vertical line test, it is a function. So if you look at this first shape I've got here, it looks like an oval. If I pass a vertical line through that anywhere, just about, it will pass through more than one point. If it passes through more than one point, that makes it not a function. But as you can see in my other graph here, if I pass vertical lines at different places, I'm only going to have one point of intersection. So this is a function for sure. Now let's talk about the domain. Now looking at the graph here, you really can't, the picture did not have arrows, but they should have arrows on the ends, so I'm going to draw those in there. So if you look, here's your x-axis. Your domain, you know, are the x values. Well, it looks like my graph's going forever in that direction to the left, and then again up here forever to the right. So we probably cover up, there's a point on this function for every value of x. So x would be, the domain would be all real numbers. All real numbers. If you wrote that in interval notation, if you remember doing interval notation with inequalities, it would be from negative infinity to infinity for the domain. The range, however, is the y's, and in this case, since this graph here to the left looks like it's going down, so it's probably going down forever. So it's going to negative, the y value will get lower and lower and lower, get to negative infinity. And this has got an arrow pointing upward, so it's increasing forever, or going up forever. So the range also looks like it is all real numbers as well. Interval notation from negative infinity to positive infinity. So hopefully that gives you an idea about what a function